going to be spending a couple days in section 1.5. So we need to go over some properties of exponents, and I want you to be able to write an expression in expanded form and also to simplify an expression using the properties of exponents. So let's first talk about the difference between expanded form and exponent form. Expanded form just means simply you're going to write out what this means. So this means write A down 2 times. This means write it down 3 times and multiply. It's multiplied by itself 3 times. This means you're going to multiply it A by itself 4 times. So this is the exponent form. This is the expanded form. Now, down below here, I would like you to write in a couple of different things. The first 3 things look very similar, but if you were to plug values in for x, they would be very different. It's extremely important to know where the variable is, or where the exponent is applied. Here, the exponent is only applied to the x. Here, the exponent is applied. So let's go back up here and talk the rest of this out. So negative 4 is not raised to the 5th power, only the x. So we would write negative 4 out here, and then we would expand 5x's. Now the parentheses are around the 4x to the 5th. So that means I am writing, oops, there's actually this worksheet's a little bit wrong here. I need you to move these parentheses. I need you to put a parenthesis right there, or it won't match up with this. So we're going to scribble this part off. Or actually, let me just take that off. So the worksheet has a misprint on it. We want to take this parenthesis off. And now we have 4x is going to be multiplied by itself 5 times. The negative sign is not raised to the 5th power because it's not inside the parentheses here. So that would be the expanded form. Now the parentheses is around the entire expression, negative 4x. So now we have to write that out 5 times. So be really careful, pay close attention to the exponent and what it is applied to. Okay, now we have 4x cubed. The 4 is not raised to the 3rd power, so we list that only once. X has to be multiplied by itself 3 times, and the y plus 6 has to be multiplied by itself 2 times. Okay, so that is the expanded form. Now, this is a very important property. It's called the zero exponent property. Anything to the 0 power is always 1. A is not 0. So 8, we can't have that be 0. So 38 to the 0 power is 1. I could make a whole long expression. I could do 1,968 a squared b cubed c, raise that to the 0 power, and it would equal 1. Now I'd like you to write a couple of things up here as well. There is a difference between negative 1, well, let's use a different number there. Let's use a 3. Negative 3 to the 0 power and negative 3 to the 0 power. Here, it's only the 3 that's being raised to the 0 power because this is actually like saying there's a negative 1 here. So negative 1 times 3 to the 0 power. So this would equal negative 1. Because the 3 is being raised to the 0 power, it changes to 1, and we still have that negative 1 outside. So we multiply negative 1 times 1 to give us a negative 1. Here, we have negative 3 to the 0 power. This whole thing is being raised to the 0 power, so that ends up being 1. So just be real careful, again, where your exponents are being applied. It's very, very important. The next property that I want you to go we want to review here is the negative exponent property. When you write your final expression, you cannot have negative exponents. So this property allows us to get rid of a negative exponent. So basically what you do, if you have a negative exponent, we can put this over 1, you take the reciprocal and the negative exponent changes from a negative to a positive. So we take that to the denominator. But again, a cannot be 0 because if we take the reciprocal there, we'll have 0 in the denominator. So let's just do, here's an example. 3 to the negative 4th power. This can be over 1. I'm taking the reciprocal, so that turns into 1 over 3 to the 4th. And 3 to the 4th is 3 multiplied by itself 4 times. So that would be 1 over 81. It's not 3 times 4, it's 3 times 3, which is 9, times 3, 27, times 3 is 81. Okay, so here's an example with negative, it's a fraction inside the parentheses, and we're raising it to a negative exponent. We're going to take the reciprocal, and now we have to cube the numerator and the denominator. So you could write it out like this, or we can use the properties, which say I'm going to cube the numerator and cube the denominator. So I could just say 5 cubed is 125, 2 cubed is not 6, it's 8. So you can jump right to this stuff, or sorry, right to this step, because you don't have to expand it. Properties of exponents just say that I raise that to the 5th, or sorry, take 5 and cube it, and I take 2 and cube it to end up with 125 over 8. Okay. When we go to this one, again, pay attention to where the exponent is. Here it's on just the c, so I'm going to do c times c times c. And because it says expanding, we're writing it out. So again, expanded form is different than exponent form. All right, now the 3xy, the entire thing is in parentheses. So we have to raise 3 to the 4th power and xy to the 4th power, that whole thing together. So we're just going to say 3xy. Now again, we're just expanding it. We're not finding out what it actually is. We're just writing it out. And here we're expanding. The cubed is on the 3, so I say a times a times a. This is squared, so I say b minus c, b minus c. Okay, now we are going to evaluate or find a value for each problem here. So we have a negative 1, which means can't have a negative exponent. I'm going to put this number over 1. I'm going to take the reciprocal, which is 1 over 6. That's raised to the 1st power, so my answer is just 1/6. Okay, anything to the 0 power. Remember, we have the 0 exponent property that tells us anything to the 0 power is 1. 12 I can put over 1. I take the reciprocal, and that's going to give me 1 over 12 squared. Now, this would be 1/12 multiplied by itself. Another way you can think of it is we have to square the 1, we have to square the 12. So this is going to be 1 over 144. Another example, some more negative exponents. We're going to take the reciprocal. So this is over 1. Take the reciprocal, I have 1 over negative 4 raised to the 3rd power. So 1 cubed is 1 times 1 times 1, so that's just 1. And this would be negative 4 times negative 4 times negative 4, which is going to be negative 64. Okay, another negative exponent. Taking the reciprocal, I have 7 over 1 squared, which is 49. Taking the reciprocal here, I have 4 over 3. Exponent changes from a negative to a positive, so that makes that cube. I have to cube the numerator, cube the denominator. So that's, again, 4 times 4 times 4, which is 64. And 3 times 3 times 3, which is 27. Okay, here's one you want to be careful with. This 0, 5 is being raised to the 0 power, so that makes it 1. And this is actually like negative 1 times 5 to the 0 power. So negative 1 times 1 is going to give you negative 1. Now, if I had given you this, that would be just a positive 1. Okay, this exponent is already positive. So we just need to square that negative 2, which is 4. We're also going to square the 5, which is 25. Negative exponent again. This negative is on the outside, so we're just going to put that on the outside. We're going to take the reciprocal of this, so it'll be 3 over 1, and that's what gets squared. So we have a negative on the outside, and 3 squared is just 9 over 1 would just be 9. All right, we're going to flip that over, and we're going to do some properties of exponents. So with your properties of exponents, there are 3 properties that we're going to go over. When you have the same base, There are three different things that happen, but you first need to make sure your bases are the same. So when you have a base raised to a power multiplied by a base raised to a power, you add the exponents. And I want you to write an example up above with the same base here. So if we have a cubed times a squared, and if we would expand this, it would be 3a's and 2 more a's. So I would have a total of 5. That's why when you have two bases that are the same and you're multiplying, you add the exponents. Now when you have, we're going to go back up here again, when you are dividing and the two bases are the same, we subtract the exponents. So let's again go back to what we know. We can expand a cubed over a squared, and that would be a times a up here. And this is just showing you why this property works, so you don't have to write it out all the time. This is a shortcut for you. So an a over an a is 1, a over a is 1, so we just end up with a. So basically, if I'm dividing, I subtract my exponents. The next one, again, we'll write it out expanded so you can see that this property actually works. If you have one base and you're raising a power to a power, you're going to multiply. All right, so let's use the same. Let's use a cubed, and we'll square that. And we'll see why we would multiply. So this a cubed means write it 2 times. So a, that's a cubed. One more time. So basically we get 6. So that means you're going to multiply those exponents together. So we don't have to expand everything like this. These are shortcuts that we can use when we're solving. Okay, so the last 6 questions here have already been started for us. So let's go ahead and finish them up. We're squaring, so that means everything inside has to be squared. So -5 has to be squared, a has to be squared, and then we have b cubed that's being raised to a power, so we're actually multiplying these exponents. So that's going to give me 25 a squared b to the 6th. Okay, now we have bases that are the same. When we're multiplying bases that are the same, we add the exponents. So that's why they did the 2 plus 4 here. And then here the bases are the same, so it would be 5 plus 3. And we just simplify this by saying it's w to the 6th, x to the 8th. Okay, now we have a couple things going on here. We have bases that are the same, but remember from order of operations, we need to take care of the exponent. So when we have a base and we have an exponent raised to an exponent, we have to multiply those exponents. So that's going to give us, we have the y to the 4th here. I'm going to bring this down. And then they basically put the y's together here. So this z cubed is right here. And then we have y -1 times 2. So that's going to go right here. And we also have z, and this is to the 1st power. So we multiply 1 times 2, which is going to give us z squared. Okay, now we have the same bases. We need to add the exponents. So 4 plus a -2 is going to give us y squared. And then same bases again, add the exponents, z to the 5th. All right, now we are dividing. So what we're going to do is we're going to divide the numbers, and when we divide, we subtract the exponents. So this is a 3, this is a 1 on the s, so it's s to the 3 minus 1, and this one is t 1 minus 2. Okay, so this is just going to change to 2. Then we have s squared, and we have t to the -1. Okay, we have a problem here. We cannot have negative exponents. That's one of the rules when you simplify expressions with exponents. So going back to the other page here, tells us that if we have a negative exponent, we just take the reciprocal. So basically what happens when we take the reciprocal of t, t is t over 1. So we just move t from the numerator to the denominator. So this is going to equal 2s squared over t. And then you're done. Now we have a fraction where we have a base raised to a power raised to another power. So this means we have to multiply those two. So it's going to be a to the 12th So they did 4 times 3. And then don't forget the denominator. That gets forgotten a lot. So it's going to be b squared times 3. And then we have a to the 12th over b to the 6th. And you're done because you have only one variable. So the variables are not listed more than once. You have no negative exponents, and your fraction is reduced. Okay, last one. We have to just be careful. There are no exponents we need to take care of. So there's nothing out here. So basically what we're going to do is we're going to multiply the numbers. So that's right here. We're going to look for the bases that are the same and add the exponents. So negative 2 plus negative 1. Then we have y cubed and y to the 5th. So it's 3 plus 5. So when we multiply, now we're just going to simplify this. We have negative 18, x to the negative 3, y to the 8th. Problem is we have a negative exponent. And the negative exponent is only on the x. So that's the only thing that gets moved to the denominator. So we have negative 18, y to the 8th. And then this moves us to the denominator. So we have x cubed. Oh, and I just noticed here that I did negative 3 times 9 is negative 27, and that's not correct. We need to make that a negative 27. That's what happens sometimes when you make the videos after a long day. Okay, so just looking back here, we have everything simplified when we have no negative exponents. We have no variables that are repeated. And we have we don't have any negative exponents. So let's just write that down at the bottom. When we're done, we have no duplicate exponents. So basically no other, if you have an x in the numerator, you can't have one in the denominator. We have no negative exponents. And our fractions are reduced.